NVIDIA, like I said, is a platform company. And what we do is we create the underlying horizontal infrastructure for third parties to build on. And when I started at NVIDIA about 5 years ago, almost 5.5 years ago now, we spent time with NREL and others in the energy industry, and we talked about some of the big problems that they saw coming and where NVIDIA technology could be best utilized, specifically for energy. And one of the guys at NREL introduced me to the CTO of Utilidata, Marissa Humman, who worked at NREL, and she went to go work for Utilidata, and she said, these guys have a really strong solution for power flow optimization, and they're looking to move this out to the edge and create a platform, and they need more compute power. And we're an accelerated computing company that are looking to accelerate applications. And so when we sat down with Marissa and her technical team and we started looking at the capabilities of what they were trying to build, we knew that there was a relationship where we could take our technology and create a differentiating solution in the market, but also an open platform in which third-party participants could come and get on board as long as there was enough compute, and similar to smartphones and other things, the ability to take the waveform, electric waveform data at a very high resolution and serve it up to applications. Now, individual companies or software providers or consulting firms or others could all be building on a common platform. And we could focus on the security and the platform and the ability to support it with software development kits and capabilities that many other companies couldn't do, but we didn't have the energy expertise or the electrical expertise. And so we partnered with Utilidata, and since that time we've got quite a few of these devices at different companies. We've received a bunch of DOE grants, and I won't take away all of Dennis's story here, but I think it's a really cool story. And our Inception program, which is designed for AI startups, we've got over 16,000 AI startups we're working with, and about 600 of them are in the energy space. And so it's in our interest to help these companies find problems, solve problems, and then build businesses. And if they're successful, we will be successful. But we take this market and we try to figure out where we can make impacts. And really happy to have partnered with Utilidata. And since Dennis has been on board, we've continued to grow our opportunities together. So let me turn it over to Dennis.
Yeah, thanks, Marc. Thanks everyone for allowing us the opportunity to share a little bit about our partnership with NVIDIA. Like Marc said, my name is Dennis Luong, Director of Business Development with Utilidata, and it's been a pleasure to work with folks like Marc and Jay in the room at NVIDIA. We're going to share a little bit about what we're building together, what that application is for this market, and some of the implications that we think are really relevant to the conversations we've already been having this morning. And so I'll jump right in. This is Carmen. Carmen is the first native distributed AI platform exclusively designed for the grid edge. It's a custom NVIDIA GPU, hardened and secured specifically to be deployed on the grid. Currently, it's analyzing 350 million data points per hour, which would be something like 6 terabytes of data per year per device. It is, like Marc mentioned, a completely open platform. We're building it kind of in the same playbook as NVIDIA, saying we want software companies, we want other vendors, we want our partners in the room to build on Carmen so that utilities ultimately get the best solutions possible, the best combination of all the expertise that we have. We're thinking through the lens of interoperability. You've already made significant investments in your operational technology, so ADMS, DERMS, your other systems. How do we interact with those systems? How do we leverage those systems and help those systems reach the ROI they were intended when you first put those online? We want to support those. And then we have 100x computational power, thanks to NVIDIA and their amazing GPUs, than the current market solutions. And that may sound like a lot. The number one question we get when we talk about that is why? Why would you put that much compute power at the edge? I'll talk about that in a little bit. Jensen Huang, earlier this year, NVIDIA's CEO, was on stage with Pedro Pizarro from SCE at EEI. And he said, to have an intelligent grid, you first have to have a software-defined smart grid. We're working together with Utilidata on an AI meter and deploying AI computers integrated into the grid. And Jensen was talking about this Carmen solution that we've built together, and we were just introducing that to the market in 2024, 2023. But I love what he's saying about a software-defined grid. We are very, very good as an industry at building infrastructure, at building hardware. And we need to help to digitize and revolutionize that hardware in order to see the capacity that needs to be built, in order to provide the solutions for customers and DERs that we need for the future. And so a software-defined grid does not get rid of the hardware, it just enhances the hardware and accelerates the use cases for that hardware. Like Marc mentioned, we partnered starting in 2021. Back in 2021, NVIDIA was not quite as popular as they are today, but we were really lucky to make a great introduction to them. We had already been working on machine learning software for the grid for 6 years prior, and so our grid expertise, understanding of the cybersecurity measures, the operations of the grid, was relevant to the partnership with NVIDIA. And then in 2023, our first handful of customers got DOE support for scaling Carmen across their footprint. And then in 2024, our friends at Hubble and Aclara decided earlier this year that they would partner with us in bringing Carmen into a meter solution for residential meters. So this was mentioned actually in the panel prior, and I was going to wave at Marc and say, hey, stop taking my talking points. But I think I have a graphic, so that's better than Marc just talking about it. So today, we have all these edge devices, right? Every single thing in your house, every single device that you own is connected. It's collecting data. And Marc was talking a little bit about what to do with all of that data. Now, the infrastructure and networking folks in the room could tell me that shipping 6 terabytes of data per device back to the cloud might be a little cumbersome. I think we calculated if you have a million customers and you're an IOU in the room, that's 6,000 petabytes. I didn't even know what a petabyte was until earlier this year. I couldn't comprehend that. And so we know that we cannot train models in this fashion. That is way too cumbersome. There's way too much data transmittal, and we don't need all that data to go into our models. And so that's where Carmen comes in. We can collect and process and analyze that data right at the edge and send the most relevant data from those devices back to the cloud, back to the data center, to the large language models that Marc was mentioning, process that and send that information back out to the edge to where that smaller language model can learn from the findings of the large language model. And we believe this is a way to help us increase and accelerate the opportunity for all that right now abandoned or neglected data that's sitting on the edge of our grid. So why distributed AI? I think it's pretty simple. We'll see a massive cost savings. We don't have to, we can leverage our existing infrastructure and increase the capacity in our infrastructure. Security is number one for all of us in terms of operating the grid. And we're lucky to partner with NVIDIA because they're best in class in figuring out how to securely and safely do AI. Speed, obviously, doing models at the edge helps the decisions to be more dispersed throughout the grid rather than centralized. And then you can use your OT software and your OT technologies to do the centralized computing. And then resiliency and better results. We just believe that there's opportunity for use cases that we don't even understand today in the future. I'm a big analogy guy, and so I'm going to go back to something Marc mentioned actually about smartphones. 20 years ago, actually maybe more than that now, this Motorola Razr was on the left-hand side, and it was limited by hardware. It didn't have that much compute power. We had a certain set of applications. You could only process so much on your phone, make phone calls, maybe take pictures. And then whose favorite phone that they owned was a BlackBerry? Who thought that was like the pinnacle of phones, right? You could do email at lightning speed. The BlackBerry had a full keyboard on it. And you guys are laughing, but I know the average age of this audience. Every one of you thought that the BlackBerry was the pinnacle of the phone, plus the little Motorola headset that you wore on your ear on one side because that was the cool way to make phone calls. That was an evolution that is now outdated by more than 15 years. And so now we're looking at, like Marc mentioned, we're looking at a software-defined solution that sits in our pocket that is relative to what 20 years ago would be a supercomputer, where we have all these applications, we can do over-the-air updates, and we can figure out what we need for the future. Carmen is looking to turn existing infrastructure into AI-enabled infrastructure. That is your meters at your house, your EV chargers, your transformers, your capacitor banks, all the way up to the substations. Embedding this AI tool inside of those devices and allowing it to read 350 million points of data and learn locally, as well as potentially send control signals locally, will enhance all of these use cases. We're going to get real-time visibility. We're going to create a DER gateway for EV and solar integration. We're going to have a hardened grid that responds to outages faster and more effectively. We're going to be able to meet the rising demand of these data centers and maybe reduce some of the load of what we need to send to the data centers. And then we're going to improve our customer service, because ultimately we serve our customers. And so we're going to look to provide better, more accurate, more transparent service to them. Let me give one quick specific example that I think the folks who want to dig into it might find interesting. So on the left, you see some purple spikes come down in this chart. And we're really looking at anomalies and transformer overloading here. And so you'll see the spikes. And then on the right, we're looking at the margin, and then we're in the orange on the bottom. That's where we're saying, hey, that's an incident on that transformer. We've categorized that with this utility, and they've said, hey, that's when it spikes into there, that's an incident. We're gonna start tracking those. This is on 10, I think 9 or 10 meters. You have 100,000, 500,000, 2 million, 5 million meters. If we can track and look at this data in real time, if we can chart and put a language model to this data, we can figure out how many times does that transfer going to overload before it blows? Where should we replace the next 10 transformers? It'll inform our asset management. Where do we have more capacity on our grid, and where do we not? And where can we leverage our DERs? And so this is just one small example. Currently, Carmen is running 5 concurrent simultaneous AI models and has room for 90+% more on the chip. And so we're excited to expand that with our utility partners and grow the models on the chip. And as mentioned before, the DOE is on board with this as well. We've seen that through them providing funding to accelerate this. But we also know the transition to a clean energy future comes with a lot of work from folks in this room. And so that's why we have a partnership with not only NVIDIA, but our folks at Hubble, saying Hubble and Aclara, they're hardware experts. They've been building things for the grid for many, many years. We're going to bring our expertise of grid operations and software, and then NVIDIA is going to bring their world-class ability to provide GPUs and compute power in a secure manner. Thanks for your time.